Let's take a look at trinomials where the lead coefficient is not equal to 1. So our lead coefficient A is not equal to 1 in each of these. We're going to go through a really easy step-by-step process, no guessing involved, so that you can get to the answer, that factorization, every single time. Our goal is to factor it into two binomials. Now, I also have a video if you're looking for factorizations where the lead coefficient is equal to 1. Let's dive into this one. I've got a 2x squared and a 5 at the end. I want to multiply the two outer coefficients. So I'm going to multiply the 2 times the 5, and those are equal to 10. And I'm going to look for pairs of numbers that multiply to be 10. I do want them to add to be that middle term, which is 11. But what we're going to be doing is branching that middle term into 2. And this is the trick. This is what makes our factorization so easy. Now, everything is positive in this problem. So as I'm doing my factorizations, I'm going to go ahead and choose two positive numbers to multiply together. So I could do the 2 times the 5. That multiplies to be 10. But when I add those two together, I end up with 7. So that one does not work. I could also do 1 times 10. Now, this is exactly what I need. 1 plus 10 is equal to 11, and 1 times 10 worked to multiply to be equal to 10. So I'm going to use that as a 1x plus a 10x to replace the 11x in the middle. Let's go ahead and rewrite what we've got right here. So I'm going to bring the 2x squared down, and I'm going to split up the 11x into plus 1x, and you can honestly write this in either order. It works out every single time. And then I'm going to do the 10x. Okay, so there is the 11x just split up, and then I want that plus 5 in the end. Now, when I'm doing this, I'm splitting these into 2. So I'm going to have a first pair and a second pair, and I'm going to look for GCFs. So I'm going to look for greatest common factor. What goes into these just as a pair to start? So I'm just going to look at the pair in yellow for right now. If I'm looking at 2x squared and 1x, what divides into both of those? The GCF for this pair, only an x goes into both of those. So I'm going to divide out or factor out an x. The x is part of my answer, so I'm going to bring the x out in front, and then let's go ahead and simplify these. 2x squared divided by x is 2x. And then 1x divided by x, that's x divided by itself, is equal to 1. So I'm finished with the yellow group. Next, let's look at the next pair, which is this 10x plus 5. I want to know what divides into each of these. So my GCF here, what goes into 10 and 5, that would be a 5. So I can divide both of these by a 5. The 5 comes out in front, so plus 5. What am I left with? 10 divided by 5 is 2, and the x sticks around, so I get a 2x. 5 divided by 5 is equal to 1. Now, if you've done factor by grouping before, this step is factor by grouping, but it works out really nice, really easily every single time for these problems. Now what I've got really is a brand new GCF. I've got this 2x plus 1 that shows up in both of these terms. I can go ahead and factor the 2x plus 1 out in front, so 2x plus 1, and I'm left with an x from the first group, so I want parentheses, an x from the first group, and a plus 5 from the second group. This is my answer. So I did that factor by grouping stuff in the middle, but it got me to my answer in just 2 additional steps. If you wanted to check and make sure that this was in fact your answer, you would FOIL this factorization out and make sure that you can get back up to your original problem. Let's do another one so the process gets easier for you. So in this one, another trinomial, I know that my goal is to get this factored into 2 binomials, but I first want to do that work of splitting up the 19x. To do that, I'm going to multiply the outer coefficients, 5 times 12. 5 times 12 is equal to 60. I'm going to look for pairs that multiply to be 60, and I want them to add up to b. b is my middle coefficient, so I want those to add up to 19. Everything in this problem is positive. So as I'm looking at these, I really want a positive number times a positive number. That's a nice place to start. Now, I could do things like 10 times 6. That multiplies to be 60, but when I add those together, I get 16. It's close, right? But not quite. I could also do, we could do 5 times 12, but again, I add those together and I end up with 17. We can do 4 times 15. I think this one's going to do it. 4 plus 15 is equal to 19. This gives me that middle term that I was looking for. So I'm going to split that middle term up as 4x plus 15x. Okay, so as I split that one up, here comes my brand new polynomial. I get 5x squared. I split the 9x up using what I found over here. The order doesn't matter. So plus 4x plus 15x plus 12. Now I'm going to find some GCFs and I'm going to group these off in pairs. Here comes the first pair. I want to know what goes into 5x squared and 4x. I'm just looking at the yellow terms, and that GCF is equal to x. So I'm going to divide both sides here by x, and that's going to allow me to pull the x right out in front. And as I divide 5x squared by x, I get 5x. 4x divided by x is a 4 parenthesis. Now let's do the next group. So the next group is a 15x and a 12. So I'm looking for a GCF there. No x's in common, but 15 and 12 are both divisible by 3. So my GCF here is going to be a 3. I'm going to divide both of these by a 3. And instead of just writing a 3 out in front, I'm going to write a plus 3 so it holds its place in the polynomial. So make sure you put that sign there as well. What do I have left? 15 divided by 3 is 5, so I get 5x. 12 divided by 3 is 4. No coincidence, I ended up with the same factor in the parentheses, that 5x plus 4. This 5x plus 4 can now be factored out in front. So I've got the 5x plus 4. That leaves me with an x on the inside and a plus 3 inside the remaining set of parentheses, x plus 3. This is our answer. So I had that work in the middle of splitting up that middle term, and then I had to do some factor in pairs, but once I'm there, I came up with my answer. Now again, either order of those parentheses work. Here comes another example. So our next one, 9x squared minus 66x plus 21. These are kind of larger coefficients. The very first thing I always want to be thinking about, and it didn't apply to the last few, is a greatest common factor. Does anything divide into all 3 of these? And there is a greatest common factor. Into the 9, the 66, and the 21, I can divide a 3. This is going to simplify things a lot for me. So let's go ahead and bring that 3 out in front. That leaves me with 9 divided by 3, or 3x squared. 66 divided by 3 is negative 22x, and then 21 divided by 3 is 7. I'm going to be working with what's inside the parentheses as I move on to that next step. I've got a middle coefficient of negative 22, so negative 22, and my new outer coefficients are a 3 and a 7. So I want 3 times 7, which is equal to positive 21. Now I want pairs of numbers that multiply to be 21 and add to be negative 22. So I need both of these to be negative. Otherwise, I could only multiply 2 positives together. I'd never get there. Now I could start with negative 3 and negative 7, but if I add those two together, it's not going to work. I could also do a negative 1 and a negative 21. I add these together and I get that negative 22 that I was looking for. So these are the coefficients that I need to split that term up. I need negative 1x and a minus 21x. This is going to give me negative 22x, and I can split that term up in the middle. Now the 3 is going to tag along, but I'm ready to write out my 2 new middle terms. Negative 22x is now negative 1x minus 21x. Again, the order doesn't matter. It will work out whichever order you put those two in, so don't worry about that. And then plus the 7 on the end. I'm going to break these into pairs. So here's my first pair. Let's just deal with the pair in yellow first. I'm going to bring that 3 here. And then I can factor out from the 3x squared and the x, just an x. So I'm going to divide by an x here. The x is going to come out in front. 3x squared divided by x is going to be a 3x. And then negative 1x divided by x is negative 1. Now I've got my second pair. I'm going to make sure and grab that negative sign. Negative 21x plus 7. Now I know exactly what I want in the parentheses, right? I want this to match. Negative 3x minus 1. So what do I need to factor out here? Definitely a 7, but I want the signs to be opposite. So I need to factor out a negative 7. Look how easy that is once you know what your goal is. Okay, so I'm actually pretty much there. I've got my new greatest common factor, that new common factor of 3x minus 1. I've got the 3 on the outside. I'm going to put everything in square brackets just so you can see what I did. I'm going to bring that 3x minus 1 on the outside, so factoring that out. I am left with the x and the negative 7, so x minus 7. Now you don't need those square brackets there, 3x minus 1, x minus 7, or you could switch the order of those parentheses. Either way, this is our factored form. Let's do one more. Here's our last one. If you are feeling good about these, and I have a feeling that you're doing really well, you can go ahead and pause this video, come up with a factorization, hit play, and see how you've done. So I'll see you in a couple of minutes. Otherwise, you can stick around and follow me. I do want to look for a GCF. There isn't one, so I'm stuck with what I've got. So my next step is to go ahead and take those outer coefficients and multiply them together. So I'm going to multiply the 4 times the negative 25. That gives me negative 100. I am looking for two numbers that multiply to be negative 100, and I want them to add up to be that middle coefficient, so I can split that into 2. So I want them to add up to negative 15. You might be pretty quick at guessing. I know that I need this to multiply to be a negative and add up to be a negative. So I need 1 to be negative and 1 to be positive. Okay, so here we go. So if I were to do like negative 10 times 10, that works to get negative 100 for a product, but it gives me 0 as a sum. So that's not going to work for that one. How about negative 4 times 25? Again, that multiplies correctly, but if I add those two together, I end up with 21. How about negative 5 and 20? They multiply to be 100, but when I add them together, I end up with 15, which is so close. I just wanted negative 15. I just need to switch the sign. So I'm going to use a 5 and a negative 20. That's going to split that middle term into a 5x minus a 20x. Okay, let's rewrite what we've got. So we still have the 4x squared. I'm going to split the negative 15x using these two terms that I just found. So that's a plus 5x and a minus 20x. And then I still have the negative 25. Let's split these into two groups. So I'm going to do the yellow pair first. Definitely an x divides into everybody here. So let's go ahead and factor out the x. So an x comes out in front, and we're left with the 4 sticks around. X squared divided by x is x. So how about 4x? 5x divided by x is a plus 5. Now, I know what I want to get, right? This has to work out over here to be a 4x plus 5. This helps me with what I need to factor out. Let's see, to get from a negative 20 to a 4 and a negative 5 to a 5, I need to divide out by a negative 5 for both of those. So a negative 5 is what lives out here in front. Okay, perfect. So I've got my brand new common factor, that 4x plus 5. I'm going to move it out in front. So 4x plus 5. And then in the second set of parentheses, I get my x and my -5. And that is our answer. If you had your binomials swapped with the x minus 5 first, that also works great. Now I do have another video on factoring. Take a look at it right here. You're doing so great. Keep up the practice, and thanks for watching.